We have a few different approaches that we can use to solve a system of equations. The first one that we'll look at is how we can solve that system graphically. If we think about solving a system of equations graphically, then the xy coordinate pair that's a solution to our system, our linear 2x2 system, is the point where the two lines intersect. So if we can graph our two linear equations and find a point where they intersect, that point of intersection will be the solution to that system of equations. We have two lines graphed here, and these are the equations that we looked at in example 1. First, we have y equals negative 2x minus 11. And that's graphed in red over to the right. And then we have y equals 5 halves x minus 2, which is graphed in blue. So in this case, we already have our two lines graphed. Once we have that graph complete, we just need to find that point of intersection, and that gives us the solution to our system of equations, because both graphs are true for that specific xy coordinate pair. Looking at our axis, we can see that this is at x equals negative 2 and y equals negative 7. So our point of intersection would be the coordinate pair negative 2, comma negative 7, which we know is a solution because of the work that we already did in example 1. If the graphs aren't given to us, then it's going to be an extra step up to us to actually graph the two equations that we're given and find that point of intersection. This will obviously depend a bit on how well we draw our lines and how well we find that point of overlap. But to start off, we'll look at graphing our first equation, y equals 1 half x minus 4. We know, since this is written in slope-intercept form, that this graph will have a y-intercept at 0, comma negative 4. And then we can use rise over run with the slope of 1 half to find a next point by moving up 1 and to the right 2. Since finding our solution accurately is going to depend on how well we draw our line, it may be useful to graph plot more than just 2 points. So we could move up 1 again and over 2, up 1 and over 2. We could move in the opposite direction too by reversing both of those directions. We could go down 1 and to the left 2, down 1 and to the left 2. As long as we're plotting enough points so that we can draw an accurate straight line and see which points that line is passing through. Again, the better picture that we draw, the easier it's going to be to find our solution. Now for our second equation, we have y equals 5 halves x minus 8, meaning we have a y-intercept at 0, negative 8, and a slope of 5 halves. So to get our next point, we'll move up 5 and over 2, and see that we overlap at this point right here. Then we just need to identify the x and y coordinates of that point, which in this case would be 2, comma negative 3. So the solution to our system of linear equations in this case would be the coordinate pair 2, comma negative 3, which we could verify like we did in example 1 by plugging those values into each equation. We'll repeat this process one more time with two different equations. In example 3, we have y equals negative 2x plus 6. So our y-intercept will be at 0, comma 6. And then we have a slope of negative 2, which is the same thing as negative 2 over 1. So to find our next point, we'll move down 2 and to the right 1. We only need 2 points to make a straight line, but if we continue plotting points, it'll just help us draw a better picture to help us more accurately find that point of intersection. Especially helps me because I don't draw the best straight lines. And then we'll move on to our second equation, y equals x. Keep in mind that this is the same thing as y equals 1x, or even 1 over 1x, plus 0. So our y-intercept will be at 0, 0, and then our slope will be up 1 over 1. So we'll go up 1 over 1 to find the next point. Repeating that one more time will give us that point of intersection between these two lines. And once we find a point where our two lines intersect, which in this case occurs at the point 2, 2, we have the solution to our system of linear equations.